What's up? Good to see you again. All right, we're going to be following up on the product rule that we just learned in our last video, and we're going to be learning what's called the quotient rule. And as you hopefully know if you're here, because you're probably in a calculus class, the quotient rule applies to finding derivatives. And what it is specifically is this. It's when you're going to find the derivative of a function that is written as a quotient. Well, how is it that you go about finding the derivative of a function written as a quotient? Well, here's what the situation is when you would use a quotient rule. If you ever have a function f of x that's written as u of x over v of x. This is the function written as a quotient that I was talking about. What might that actually look like with functions in place there? Well, it could look something like this. F of x equals e to the x power over the square root of x. All right, so you see that that is a quotient. Now, brace yourself. Here's what the quotient rule says formally is the way you determine the derivative of such a function. It says that f prime of x is equal to v of x times u prime of x minus u of x times v prime of x over v of x squared. Now, looking at that, you're thinking, how in the world am I ever going to memorize such a complex-looking rule? Well, what we're going to do is we're going to think of it in simpler terms. What I'm going to show you is what my high school teacher, Mr. Chandler, showed me. Shout out to Mr. Chandler. Hopefully you're still teaching this stuff well. Now, let's go ahead and think of, instead of a u of x and a v of x, let's think of it as we have a high function and a low function. I think that makes a lot of sense with the numerator and the denominator going on there. And then here's how you would remember what the derivative of that high over low function is. I'll be abbreviating the words high and low here. F prime of x would equal low d high minus high, all right, the higher function, times the derivative of the lower function over the lower function times itself. Now, that might not seem like it helps you remember anything quite yet. Just remember the d is for derivative. And then here's the way that you actually are going to remember it. You're going to say low d high minus high d low over low low. Low d high minus high d low over low low. Everybody now. Low d high minus high d low over low low. Rolls off the tongue a little bit, doesn't it? Okay, so I think that you could remember that. And now I just have to show you how to apply it. So let's take a look at our function that we wrote, and let's go ahead and find its derivative using that quotient rule. Here we go. All right, so low d high, that means that you take the lower function and you just write it as is. That's the low part, and then the d high is that you go ahead and take the derivative of the higher function. Now, keep in mind the derivative of e to the x is e to the x, but I did take the derivative of the higher function. That's what's written here. And then we're going to put minus the higher function, so e to the x. Now this is with, it wasn't the derivative this time. D low, high d low is what we're doing right here. So times the derivative of the lower function, and the derivative of the square root of x would be 1/2 x to the negative 1/2 power. You remember how to rewrite the square root of x as x to the 1/2 power, don't you? And then use the power rule, and you'll get what I just wrote right there. All right, so that's low d high minus high d low over low low. And the low low part means you just take the original lower function and you square it. That's it. And if you, well, I'll write this for the moment as the square root of x squared. There's my low low. All right, now all we've got to do is try to write this in a more friendly looking manner if it's possible to. It's not always possible to. And like I talked about with the product rule, often what happens with the quotient rule is in the numerator, only happens in the numerator, you end up with the different terms having a common factor. So I've got e to the x as being a common factor of each of those terms, and it's often useful to go ahead and factor out that common factor, bring it to the front. So we'll make this e to the x times, and then that'll leave us with the square root of x here in the first term, and then minus 1/2 x to the negative 1/2 power, which I'm going to write as 1 over, you know what, no, I'm not going to do that. I'm going to just write it as it is, 1/2 x to the negative 1/2 power. And then you put that over, of course, the low squared, and if you square the square root of x, you're just going to get x. So there's an example of how you use the quotient rule to find a derivative. Now there is a way to write this a little bit more neatly. Let me come over here where I've got more space and go ahead and do that for you. And I want to think of this as x to the 1/2 power. In fact, let me just erase it right there. I think you agree the square root of x is equal to x to the 1/2 power. And if you look in the parentheses here, it turns out there's a little bit more factoring we can do. We have powers of x in each term, and whenever you want to do some factoring, when each term has a power of x in common, what you do is you just factor out the least of the exponent that you have right there. Negative 1/2 being smaller than positive 1/2, I'm going to bring in x to the negative 1/2 out to the front of this thing. Now we're still going to have e to the x power, but now I'm also going to have times an x to the negative 1/2 power. And you're going to see how that makes the inside look neater. What would you multiply x to the negative 1/2 power by to get x to the positive 1/2 power? Well, you would multiply it by x to the first power, right? Because negative 1/2 plus 1 is positive 1/2. So that's where that factoring is. And then if we factor x to the negative 1/2 power out of, well, itself, then we're going to just be left with the coefficient that you had there, 1/2. So that looks a little bit neater right there over the square root, well, not over the square root of x, it was just over x in the denominator, wasn't it? All right, so that's a little trick you can do sometimes with factoring to make the quotient rule result look a little bit neater. All right, let's go over another example or two of using the quotient rule to find derivatives of quotients. Let's find the derivative of this function here, g of t equals t squared minus 4 over 5t minus 3. Now, you can already imagine what the higher and the lower terms are, because we're just talking about what's in the numerator and what's in the denominator. And let's go ahead and apply that rule. Low d high minus high d low over low low. So g prime of t would equal low d high. That's going to be 5t minus 3. All right, that's the low, times the derivative of the higher function, and the derivative of t squared minus 4 is simply 2t, minus high d low, so write the higher function as is, t squared minus 4, times the derivative of the lower function, derivative of 5t minus 3 is 5, over low low, which then would just be 5t minus 3 squared. All right, we've got the derivative. We're going to see if we can make it look any neater whatsoever. Sometimes you can, sometimes you can't. Let's go ahead and, you don't notice any common factors yet for the terms in the numerator. Let's see if after multiplication we can find some. Let's find this product first. That will give us 10t squared minus 6t. And then we'll have minus, and we'll multiply 5 times t squared. And if we have 5 times negative 4 and get negative 20, and we're subtracting that, we're really going to get a plus 20 right there, over. Now, never worry about expanding the denominator. It's just not going to be a useful thing for you too much. All right, but the numerator, it will be useful sometimes. And then let's just go ahead and combine the like terms that we've got, which happens to only be a pair of them. 10t squared minus 5t squared is 5t squared, minus 6t plus 20 over 5t minus 3 squared. There you have it, the quotient rule. Low d high minus high d low over low low. Helps you find the derivative of any quotient that you need to. All right, hope this has been helpful. See you next time, guys.